Hello, this is Ibrahim, a data scientist. I'm here once more to show you what I worked on. So what I did was I got data set from the National Quitline Data Warehouse, and it was from 2010 to 2020. So what I did was to split data set into two from 2010 uh, to 2016, then from 2017 uh, to the end. So if I imported my libraries, view my data set, check if there's any issue with nulls. You can see a lot of nulls in data set. Uh, work with the nulls, check the characteristics, check the headings. So those with nulls that are substantial, they were dropped. Those that are manageable, they were replaced with zeros. And any column that was repeating itself was dropped, as the case may be. So this is what I did. I worked on the data sets, a lot of visualization to show the gaps that happen. So this is how they were collecting data set, was training, then they changed the methodology. That's what we learned today. So the gap and change of methodology. So the age requirements. So this is about the quitline service, how it makes people to quit. They really quit after 30 days. They really quit using tobacco, the cessation of tobacco. So again, you can see how it was trending, and they changed it the format. All right. So a lot of code, a lot of visualization. Just look, go through my GitHub, watch each and every uh, visualize input variable. You'll see what I did. A lot of work to clean out data to make sure it's okay before I went on to start working with it to get if they're going to quit or not. So the heat map, the PSM, oh sorry, the spearmint correlation is not spearmint correlation because of the type of database. So being known that I use the artificial neural network, and the type of artificial neural network that I used is the CNN, the LSTM, and the GRU. Now I know they are time series based neural network. So what I did was try to condition them so that they can be able to predict for me how the people are going to quit or not to quit, be able to do the kind of classification technique with it. So a lot of work with this, able to do this because uh, over my research when I was doing this, it's because I've not seen anybody that did this work before. So I don't say I'm the first person. I can say that, but what I can say is what I research, I couldn't find anybody that have done similar thing before. So I saw people who have predicted this and this about tobacco cessation, either just from a clinic outside the US or large set of people, but not directly with this data set. So this study encompasses both America as a country, even the District of Columbia, and you have two other countries that also work with America with this data set. So we have Puerto Rico and Guam. These are the countries that US have administrative power over. So they collect the data set and they work together as one. So you have the US itself, with this you have 50 states, you have Puerto Rico and you have Guam. The training of data sets, training and validation, then we have training and validation loss. So as the model is learning the distance between, like use the word distance so people can understand the distance between the targets and what the model is predicting is getting closer and closer. So it's learning and learning and learning. So in order to avoid overfitting, you have to put a stopgap measure. So I will train it, you have to do a stopgap measure to make sure it doesn't overfit. So at the end of the day, so we have from 2010 to 2020 training, then that's the data set. So for 2010 to 2017 was used for the training. 2018 to 2020 was used for the testing. At the end of the day, we discovered that the performance gave GRE 84.05% as the best model that we used. So it was able to predict at least 4 out of 5 persons were predicted accurately with GRE. But that did well. CNN got a 2.64, LSTM got 80.43. So they also did well. But the GRE was the best in this case. I've then tuned it so that it can take up the time series of the timeline of the years as they performs. Okay. So what are the potential reward applications? You can see they help the health sector, it will help the care sector, strategy for government to also use AI to be able to help with this thing to find out what are the things that really make them to stop or not stop. So the key thing there was the insurance, those with insurance. So those insurance tend to stop. Why do insurance tend to go on with whatever they're doing with the tobacco usage? So this is a brief analysis of what's happened. You can get this and many more from my GitHub. Thank you very much.